ground the middle. So like this voltage, basically, if this is ground, this voltage would be VDC over 2, and this voltage would be negative VDC over 2, right? So that's basically what we have. And we have a load, we have two switches. Let's choose this polarity for our output voltage and this current for our output current. Now, just be reminded that if this load is resistive, it follows the Ohm's law, and the voltage, basically, like if you have like if you have a positive voltage, negative voltage here, the current always goes this way, right? If it's a resistive, based on the Ohm's law, the current always goes from the higher potential or to a lower potential. But this load can have, it can be a motor, it can be like some inductive load. So if you have an inductive load that has some initial current which is going this way, then the current can also go this way, right? So like it's going to be very simple if we analyze the circuit using resistive load, but I want to keep it general, and we're going to see that the current might be able to go that way, right? If you have an inductive load such as a motor that has some current going that way. So let's say like we have a motor like that's rotating this way. So once you have an inductor that it has the current in this direction, then the current can go from this negative pole to this negative pole, to this positive pole. So this is something to keep in mind. This is the direction of the voltage and current that we choose for our output. Now let's see what states can our switches take. So we have two switches, right? S1 and S2, right? So each of them can be either on or off, right? So we would have 4 different states based on the status of these switches. And let me actually also like put the output voltage here. So S1, oh, sorry. S1, S2, and V out. Okay, so if S1 is off and S2 is off, okay, so like there's no voltage connected to this this load, right? So there's no current. If you have resistive load, the voltage across the output, it's going to be 0 because there's no current. So R times IO, it's going to be 0. But what if like we have an inductive load that has some current in it, right? In that case, we have problem because now this current doesn't have any path to go through. There's no diode, there's nothing here. So this is not desired, like it's undesirable state. Okay. What if we have both of the switches on? So you guys remember that from the rectifier chapter that we never want to have 2 switches on the same leg to be on at the same time. Why is that? Because we're basically creating a short circuit, right? So like we have like voltage, very small resistance through the wires and through the switches, and this is going to be basically shooting out a huge amount of current, right? So this is also something that we try to avoid because this is going to cause short circuit or shootout, right? You have like a huge amount of current going through here. It might damage like everything that you have in the circuit. So these are 2 undesirable states that we have. So what is left is basically having only one of the switches on. Either S1 is off and S2 is on, or S1 is on and S2 is off. Okay, so let's first look at the this state here. So like when S2 is closed, right, and S1 is not closed, S1 is open. So S2 is on, S1 is off. In this case, you can look at the voltage across at this point and the voltage here, right? This is grounded, and this voltage, it's going to be negative VDC over 2, right? So our output voltage, it's going to be negative VDC over 2. The current, if it's resistive, it goes from the higher voltage to the lower voltage, so the current would be going that way. But if our load is not resistive, we can't make that decision. It depends on the load. So the direction of the current depends on the load. If it's resistive, it goes like from this point to this point. But let's say like if it has like if it's a motor that has some back EMF, then like this voltage depends on that back EMF. So we can't tell like if the direction of the current is always going towards this way, right? That depends on the load. And the next state would be turning this switch off and turning this one on, right? So if that's the case, then this point, this node is grounded, this point or this node is connected to positive VDC over 2, and this is what we have. Okay, so so this is the whole operation modes of half-wave rectifier. It's a very simple circuit with 2 switches that we can turn only one of them on while the other one is off. Now let's look at the output voltage waveform or output voltage signal. So we have 2 switches. We write these on this side. And we want to see how the output is going to change. Let me see if you can see the whole whiteboard. Yes. Okay. Okay, so maybe it's better for me to do this a little bit differently. Just like go it all the way here, and this is in the middle. Okay, so let's say that S1 is changing like this. If that's the case, then how does S2 look like? It can't be on at the same time that this is on, this is off. So this is basically the gate signal that we supply to this switch. If this is S1, S2, it's gonna be the opposite of that. So it's gonna be off when S1 is on and on when S1 is off. So it's gonna be like this. Okay. How does our output voltage change when S1 is on